So now we have to show that when x approaches 0, then the limiting value of sin x upon x is 1, and when x approaches 0, then the limiting value of tan x upon x is also 1. So let's proceed. Firstly, we will draw this diagram, and one thing you should know is that the area of triangle is half into base into height, and the area of sector is pi r square theta upon 360 degree. So we will use these two formulas to derive the limit. So we mark the points A, B, P. Now just by observation we can see that the area of triangle AOP is less than area of sector AOB. Right? You can just see that the area of sector is little bit more than area of triangle AOB. Now further we can see that the area of triangle AOP is greater than area of sector AOP. Now we consider the radius as r, and we drop an altitude bm. Now area of triangle AOB is half into base into height, and we have taken angle as x. So now we can easily calculate the height. We know that the height is bm, and the radius of the circle is r, which is acting as hypotenuse in this right angle triangle BMO. So we already know that the sine of x will be perpendicular upon hypotenuse. So we can easily get the value of BM, that will come out to be r sine x. Now area of sector AOB. So area of sector is pi r square, angle that is x upon 2 pi, and area of triangle AOP is half into base into altitude. Now the altitude or height is PA. So for this tan x will be perpendicular upon base. So we can get the value of PA as r tan x. So write it down, x tan x. Now we can cancel out half from each side, and r will also get cancelled out. So we will left with sin x and sin x upon cos x. Now we can divide by sin x. Now we will take the reciprocal. So the reciprocal of 1 will be 1, and the reciprocal of x sin x will become sin x upon x, and reciprocal of 1 upon cos x will become cos x, and due to which the orientation of inequality sign will also change. So let's do it. Now we will put a limit on each part. So by direct substitution we will get the value of cos x as 1, and here also we got 1. So by sandwich rule we can say the limit x tends to 0 sin x upon x equals to 1. By using this we can also prove that limit x tends to 0 tan x upon x is also 1. We have to just use the given result and prove it. Let's see how. So limit x tends to 0 tan x upon x equals to limit x tends to 0, then tan x is sin x upon cos x. Then we will distribute the limit, and we have already known that its value is 1, and so 1 will be multiplied by 1 and we will get 1 as a result. Now we have to find the limiting value of 1 minus cos x upon x when x approaches 0. So let's begin. So firstly we will rationalize the term by taking 1 plus cos x in numerator and denominator. Then we will get 1 minus cos square x in numerator. Then we have sin square x upon x. So now we can distribute the limit, and we already know the limit of first one, and we know that sin 0 is 0. We have to find out the limit sine inverse x upon x. So this limit is quite easy to determine because you have to just substitute sine inverse x by t. So when x tends to 0, t tends to 0, and you have to just now substitute in the above expression. So it is quite easy for you now. So you will do it yourself. Similarly, you can find out the limiting value of tan inverse x upon x. So you have to just substitute tan inverse x by t.